We will start our study of application of quadratic functions by doing a general discussion about quadratic functions. Quadratic functions are typically written in two ways. One is called the general form of a quadratic function, and this form is ax squared plus bx plus c equal to fx, which is the output value. If this is the format, then the graph of the quadratic function, depending on the value of the constant a, if it is positive, it will look like a parabola that opens up. So I'm just going to say opens up. If a is less than 0, it will open down. This point, which is depending on opening up or opening down, is the point of the absolute minimum or absolute maximum, respectively, is called the vertex of the parabola. And there is a fun way of writing this vertex as a point. The formula is minus b over 2a is the x coordinate, 4ac minus b squared over 4a is the y coordinate. Now, when I will actually solve problems, I will show you an easier way of finding the y coordinate so that you don't have to remember this entire formula. But unfortunately, we do have to remember the vertex formula negative b over 2a for x. The y, we can get an easier way of finding it. So again, as I have said, depending on whether your parabola is opening up or opening down, the range of the function changes. So think about if you have a parabola that, say, is looking like this, then the range, which are all the output values, is going to start at this minimum point and will go towards infinity. So that will determine the domain of a quadratic function and the range for the quadratic function. So domain is fortunately all real numbers, so it is always negative infinity to infinity for quadratic function. Range, if a is greater than 0 again, we will say the range is the y value of the vertex. So I'm going to say it this way. Y value of the vertex, so that's the coordinate, to infinity. And this is a closed bracket because you will have the graph present at the vertex. So that will be the range. Whereas if a is less than 0, then your graph in that situation is going to open down. Say this is opening down this way. Then the vertex now has become the highest point on the graph. So the range of this function then is going to become negative infinity to the y value, the height, so y value of the vertex. And it has also given us a beautiful, beautiful structural concept. And that is, if a is greater than 0, we say the parabola has a minimum. See, this point is the lowest point, so it is a minimum. So we say function has a minimum at the x value of the vertex. Oftentimes we call it the location of the minimum. And then the minimum value is the y value of the vertex. And remember, these are the information that you are getting if you have the parabola opening up. Whereas if you have your parabola opening down, that means the leading coefficient a is less than 0, then the minimum point, the vertex, has become the maximum point. So we will say in that situation, the function has a maximum. At the location is, again, x value of the vertex. And the maximum value is, just like the minimum situation, the y value of the vertex. And these are the information that are going to help us model real life situation by a parabola and talk about a lot of the features of the problem. Now, the one other way of writing down a parabola is its standard form. So standard form, or oftentimes people call it the vertex form of a quadratic equation, is fx equal to a times x minus h squared plus k. Even though all the properties are the same for this type of parabola, it is just a little bit easier to work with. So remember, we did talk about graph. It is exactly the same information. The graph, if a is greater than 0, looks like this. So we say opens up. If a is less than 0, the graph looks like this. We say opens down. Then we have talked about the domain of the parabola. And again, the domain of the parabola or the quadratic function is still negative infinity to infinity. The range, remember, it depends on the value of a. So if a is greater than 0, the range was a to infinity. I mean the y value of the vertex to infinity. So y value of the vertex this time is k. So the vertex of the parabola in this situation is actually pretty simple to find. It's h comma k. So the range is the y value of the vertex, which is k, to infinity. Whereas if a is less than 0, then the range is going to be negative infinity to the y value of the vertex, which is k. So exactly the same information, just easier. And if a is greater than 0, we say that function has a maximum, and the maximum occurs at the location x equal to h, the h coordinate, the x coordinate of the vertex, and the max, I should have said minimum, because remember, if a is greater than 0, it is opening up, so that is a minimum. So let me go ahead and change it. So it is a minimum occurs at x equal to h, and the minimum value is y equal to k. Whereas if a is less than 0, the vertex is the maximum point. So I say maximum occurs at x equal to h, and maximum value is y equal to k. With this setup, we're going to start working on our exercises. So let me insert the lecture note, and we will start working on them. Okay, so we are going to skip the first bit because we have talked about it already, and we're going to just directly start working on our problems. So the first problem is saying the graph of the quadratic function is given. Select the function's equation. So remember, fx equal to x squared being our original quadratic function, the graph we know goes through the origin and opens up. The graph in picture for this problem has a shift. It has shifted 1, 2, 3, 4 units up, so that should be a plus 4. And it has shifted 2 units to the left, so that should be a plus 2. So that means this equation is going to be fx equal to x plus 2 squared plus 4. So the plus 2 is shift left, and the plus 4 is shift up. So that's pretty simple. In general, in order to draw the graph of a parabola, we are going to talk about the x-intercepts and the y-intercepts of the parabola and find the vertex. And I'm pretty sure we will have opportunity to do that. Find the coordinates of the vertex of the parabola defined by the given quadratic functions. So I'm going to just find the vertex of the parabola. So first and foremost, remember A is going to be this number -4, H is -1, and K is 8. If it is giving you a little hard time to understand why H is -1, think about the standard form is A times X minus 8 squared plus K. But this one is not quite a minus, so what you first do, you say Fx is equal to -4 times X minus of -1. That makes it a plus and helps you understand that H is a -1. Okay? And I know the vertex is pretty simple. It's H comma K, so that is -1 comma 8. The second function is given in the general form, so I need to do a little bit of work. So the vertex, the x coordinate, which I can call H, the formula said that it is b minus b over 2a. Now my a is 2, b is -4, and c is 1. So minus of -4 is b over 2 times 2 is a. So I get minus times minus is +4 over 4, and that's 1. Now remember k, the formula was 4ac minus b squared over 4a. So if I use the formula, I should get 4 times 2 times c is 1 minus b squared will be -4 squared over 4 times a is 2, which is going to be 4 times 2 is 16 times 1 is 16 minus -4 squared is also 16. So it is 16 minus 16 over 8. So that's 0 over 8 and hence 0. But the process we're going to adapt here is a little easier. Once you have found the x coordinate, you go back to your function and replace the x by 1 and find the y. So basically find f of 1. And that should be 2 times 1 squared minus 4 times 1 plus 1, which is 2 times 1 is 2, minus 4 times 1 is 4, and then plus 1. So that is 3 minus 4, and that's -1. So I'm seeing two different answers, so I must have done something wrong, and I already see that. So see, I said 4 times 2 is 16. That should be 8 here. So that is the mistake I have done. So let me go ahead and change that. It should be 8 minus 16. So that should be a -8 over 8, and that should be a -1. Now things make sense. So now I know what is the vertex. So the k value is -1, the h value is 1, so the vertex is at 1, -1. Okay? So this problem is saying that use the vertex and the intercepts. Exactly, this is what I was talking about, to sketch the graph of the quadratic equation and give the equation of the parabola's axis of symmetry. So this problem should be pretty simple. And finally, we are going to write down the domain and range. So we'll start with the standard form of the parabola, and we'll write down h and k. So h is 4 and k is -9. Again, you have to think of this expression as x minus 4 whole square plus -9, because you want to match the standard form of fx equal to a times x minus h squared plus k. Okay, so now I know the vertex. The vertex of this parabola is 4, -9. If I look at the standard form of the parabola, I will know that a is equal to 1 because it is the constant coefficient multiplier that is greater than 0. So that tells me the parabola should open up. Now I need to find out the intercepts. So first we will find the x-intercepts. These are the points where the graph of the parabola should cross the x-axis. That means y is equal to 0. So I say set y equal to 0. And y for us is just the fx output. So I get x minus 4 squared minus 9, and then basically you solve this quadratic equation for the value of x. So easier way is adding 9 on both sides. So I get 9 equal to x minus 4 whole to the power 2. Then I take the square roots on both sides. So I get 3 square root of 9 equal to absolute value of x minus 4. Remember, it gives you two solutions. So x minus 4 is either 3 or x minus 4 is -3. So x is either 7 by adding 4, or x is +1 when I add 4. So the x-intercepts that I wanted to know are 7, 0 and 1, 0. These are the two x-intercepts. Similarly, we're going to find the y-intercepts. Now for y-intercept, I am supposed to set x equal to 0 because this is the point on the y-axis, so x is 0. That means I will get y equal to, we can think of fx as y. So put x equal to 0 in the given equation. So you get, so x minus 4 squared is what we have. So we're going to say 0 minus 4 whole to the power 2 minus 9. Negative 4 squared is positive 16 minus 9. So that's 7. So the y-intercept is, remember it is a point, so I write it as 0, 7. Okay, so I'm pretty set. I'm going to first write down the vertex of the parabola at 4, negative 9. So x equal to 4, y equal to negative 9 should be here. That's the vertex of the parabola. Parabola opens up. The x-intercepts are 7, 0 and 1, 0. So 7, 0 and 1, 0. And the y-intercept is at 0, 7. So x equal to 0, y equal to 7. And then we're going to connect these points. And that is the graph of the parabola. Vertex being 4, negative 9, x-intercepts being 7, 0, 1, 0, and y-intercept being 0, 7. The other things we are going to find out is the parabola's axis of symmetry. Well, axis of symmetry is very simple. It is kind of clear from the graph, and that is going to be the line that passes through the x coordinate of the vertex. This should be the axis of symmetry, and so the line is going to be x equal to 4 because the x is equal to 4. We're going to find the domain of this function. Now remember, because it is a parabola, the domain is always going to be negative infinity to infinity. Since this parabola is opening up, when you are finding the range, you will start with the y value of the vertex, which is negative 9, and go all the way to infinity, and that will complete this problem for us. So we're going to work out a pretty similar problem, but this time instead of the standard form or the vertex form, we are given with the general form of the parabola. So again, I need to know a, which is negative 1, that's a coefficient of x squared. B is 4, C is negative 13. Since a is negative 1, that is less than 0, so parabola should open downwards. And now we're going to find the vertex. So the x coordinate of the vertex being minus b over 2a, that's the formula. So I'm going to get minus 4 over 2 times negative 1. So this is minus 4 over minus 2. Minus minus cancels, I get 2. And remember, the easier way of finding the y coordinate. Instead of using the formula, I take the x coordinate 2 and put it back in the formula for the parabola. So I get 4 times 2 minus 2 squared minus 13. And that is 8 minus 4 minus 13. So this is 8 minus 17, and that's negative 9. So the vertex of the parabola now is found, and the vertex is the point x equal to 2, y equal to negative 9. So let me extend this thing a little bit. Now we're going to find the x-intercept. So finding x-intercept, we know that we're going to set y equal to 0 and start solving for x. So 0 equal to 4x minus x squared minus 13. Now this one will be easiest for us to find the solutions if we either use the quadratic formula or complete the square. Just to remind ourselves, completing the square, I'm going to do that. So the first step is you factor out the coefficient of x squared, which is a negative 1 here, and you get x squared minus 4x. So positive 4x, if you take out the negative 1, becomes minus 4x. Negative 13 becomes positive 13. which will be equal to, so this one is not that bad because x squared is good. You will write 2 times x times 2 because it is a negative 4x, and you have the form of 2 times the first term times the second term. Because the second term is 2, I need to add 2 squared. But because I added 2 squared, in order to keep everything same, I have to subtract 2 squared, and positive 13 was already there. So I get 0 equal to now negative 1 times x minus 2 whole to the power 2. Think about it. First term is x, second term is 2. This is a minus, so I get x minus 2 whole square. What else I have? I have negative 2 squared, which is negative 4, plus 13, which implies 0 should be equal to negative 1 times x minus 2 squared. Now I am distributing this. 13 minus 4 is a 9, and when you distribute the minus, you get a negative 9. So this means if I add 9 on both sides of the equation, I get negative 1 times x minus 2 squared equal to 9, and I can divide both sides by negative 1, so I get x minus 2 squared is equal to negative 9. To solve, I will take the square roots on both sides. So I will get absolute value of x minus 2 equal to square root of negative 9 is square root of 9 times I, which is 3i. So I get two solutions, x minus 2 equal to 3i or x minus 2 equal to negative 3i. So x is equal to 2 plus 3i or x is equal to 2 minus 3i. But none of them are real numbers. What does that tell me? There is no x-intercept. So the graph will not cross the x-axis. But I'm going to find the y-intercept, and in order to find the y-intercept, we know the process. We're going to set x equal to 0. So if I do so, I get y equal to 4 times 0 minus 0 squared minus 13, which is simply negative 13. So the y-intercept is 0, negative 13. So now I can draw the graph. I know that the vertex of the parabola is 2, negative 9. So x equal to 2, y equal to negative 9 should be here. It opens down, and the y-intercept, the point where it is crossing the y-axis, is 0, negative 13. So I have till negative 10, so this is negative 11, 12, negative 13. So the graph is going to go through this point, opening down, and will be symmetric along this line. And I needed that because I needed to write the axis of symmetry. So now I will go ahead and say the axis of symmetry for this parabola is x equal to 2. That's where the line is passing through. Domain of the parabola, well, I don't even have to think about it. It's always negative infinity to infinity. Range of the parabola, remember this parabola is opening down, so the range is going to start at negative infinity and will rise up to the y-coordinate of the vertex, which is negative 9. And that will answer my question. Let's see what else we can do with these things. In example 4, I have been asked to determine without graphing whether the function has a minimum value or a maximum value. Find the minimum or the maximum value and determine where it occurs. Identify the function's domain and range. And the function is given as 3x squared minus 24x minus 1. So it's very similar to the work that we have done so far. You determine a, that is 3, b, that is negative 24, and c is negative 1. Since a is equal to 3, it's greater than 0, so the parabola should open up. So I will just get this shape to help us down, and that's the vertex. Remember, so I have the point of minimum because the vertex is the lowest point on the parabola. So the first question is now answered. Determine without graphing whether it will have a minimum or maximum. So we'll say the function will have minimum. Now it is saying find the minimum or maximum value and determine where it occurs. So I need to know the vertex. Well, x coordinate of the vertex is minus b over 2a. So that should be minus 24 is b. 2 times a is 3. So minus times minus is positive 24 over 6, and that's 4. Okay? Think about the easier way. You replace your x by 4. So you get 4 square. Actually, I should say 3 times 4 square minus 24 times 4 minus 1, which is 3 times 16 minus 24 times 4 is 96 minus 1. So I get 48 minus 96 minus 1, and that is minus 48 minus 1, which is minus 49. So the vertex is 4 comma 40 minus 49. So now I know the answer to the second question. I know it is a minimum already, and I will say the minimum value is the y value of the vertex. So minimum value is negative 49, and where it occurs? It occurs at x equal to 4, the x value of the vertex. Identify the function's domain. That is the easiest part. Domain is always negative infinity to infinity. The range of the function, because it is opening up, it will start at the y value of the vertex, so negative 49, and goes all the way to infinity. So that will be the range of the parabola. Let's do the next problem. It is the same problem, but probably the parabola is a little different because the leading coefficient is negative 2, so it should open downwards. A is negative 2, that's less than 0. Parabola opens down. So that's the shape of the parabola. And remember, this tells us that now we have a maximum in this situation. So b is equal to 4 and c equal to negative 5, which is going to help us find the vertex. H is going to be negative b over 2a. So that's minus 4 over 2 times negative 2, which is minus 4 over minus 4, and that's 1. Putting it back in the parabola, we get k equal to negative 2 times 1 square plus 4 minus 5. Actually, I should say 4 times 1, which is 4. So I get negative 2 times plus 4 minus 5. So this is positive 2 minus 5, and that's negative 3. So the vertex of this parabola is 1 comma negative 3. So first question was, should I get minimum or maximum? We'll say the function has maximum. Second question, what is the maximum value? So I will say the maximum value is the y value of the vertex. So is negative 3, and it happens at, and it occurs, the maximum occurs at the x value at x equal to 1. Domain and range. So domain of this function is still negative infinity to infinity. Range of the function, whereas because it is opening down, it will start at negative infinity, and it will go all the way up to the y value of the vertex, which is negative 3. Okay, done. The next question is, give the domain and the range of the quadratic function whose vertex is negative 3 comma negative 7 and the parabola opens down. So this is even easier, opening down, and vertex is negative 3 comma negative 7. So clearly the domain, I don't even worry about anything, it's still negative infinity to infinity. Whereas when finding the range of this parabola, since it's opening down, it will start at negative infinity, and it will go to the value of the y coordinate of the vertex, which is negative 7. And I have answered the question. Write an equation in the standard form, so the vertex form, a times x minus h whole square plus k, where h and k are the vertex. standard form of the parabola that has the same shape as the graph of y equal to or fx equal to 5x squared, but the point seeks 2 as the vertex. Okay, so it should be pretty simple for us. We'll just go ahead and say that it should be, say, gx is the function for the one that we want. It should be 5 times, remember the format, it is x minus 2, so it is a times x minus h whole squared plus k. If this is the format of the parabola, then we say that the vertex is at h comma k. So I'm going to say 5 times x minus 2 squared plus k. It should be 5. I'm so sorry, because the given vertex of this parabola is at 6. Should be a little careful. It should be 5 times x minus 6, because this is your h and this is the k, square plus 2. That answers my question. Let's now use whatever we have learned so far in order to solve these application problems. Farmer Ed has 900 feet of fencing to close a rectangular plot that borders on a river. If Farmer Ed doesn't fence the side along the river, find the length and the width of the plot that will maximize the area. What is the largest area that can be enclosed? Okay. So from the diagram, I know that the total amount of fencing needed is going to be the 3 sides that he needs to fence. So there will be x plus 900 minus 2x. So this side, and that side, plus x. So that should be equal to 900, and it is the total amount of fencing he has. Now, what is the area of this rectangular field? Remember, the area is the length of the field times the width of the field. So for us, the area, if we consider that as a function of x, should be equal to, length is 900 minus 2x, and the width of the field is x, which is, if I distribute the x, I get 900x minus 2x squared. Now, if you look at this thing, this is a quadratic equation. So the graph of this thing is going to be a parabola. So let's find out what is A. A is negative 2, B is 900, and C this time is 0. But since A is negative 2, this parabola should open down. What does that tell me? It tells me that the parabola will give me a maximum. Now, if you read back the problem, it is actually asked you to maximize. It said that find the length and the width of the plot that will maximize the area. So all I need to do is solve this parabola, and that will give me the answers, because it is already giving me the vertex as the maximum. So I basically need to find the vertex of this parabola. So h is going to be minus b over 2a, which is minus 900 over 2 times negative 2, which is minus 900 over minus 4. Minus minus cancels. 4 goes 2 times in 9, you get 10. It goes 2 times in 10, you get 20. So that's 225. Now remember, this is the x coordinate. The k is going to be, I put that value for x back in the equation of the parabola. So I will do 900 times 225, which is the x, minus 2 times 225 square. Now this is a large calculation, so what I will do, I will go ahead and find the answers using a calculator. So let me open my calculator and then I will show you the work. So I'm going to multiply 900 with 225 times 225, and then I'm going to subtract 2 times the square of 225. So 225 square, and I should get 101250. Okay, so k is equal to 101, 250. Now see what I have done. I have already answered all the question. Remember, the width of the field is x. So I wanted to know the dimensions. Now I know. I will say the width of the plot to maximize the area is 225 feet, because that's the x coordinate of the vertex. For the dimension, I also need to find the length, and I know the length is 900 minus 2x. So the length is equal to 900 minus 2 times 225, which is 900 minus 450, and that is 450 feet. The final question asked was, what is the largest area that can be enclosed? Well, fx is the largest area, and this is the output or the y value, and the largest y value is the y value of the vertex, which is k. So I have that as well. I just say the largest area is equal to 101, 250. This is area, so I use the unit square feet, and that would answer the question. Let us do a similar problem. This problem is telling us that a rectangular playground is to be fenced off and divided into two by another fence parallel to one side of the playground. A total of 720 feet of fencing is used. Find the dimensions of the playground to maximize the total enclosed area. What is the maximum area? So what I do, I go ahead and say that let's let this total side here is y, that's the length, and this is y, and the width, let's say, is x. So I will have 3 of them because I need this middle fencing as well. And then I said total fencing in terms of x and y is going to be y plus x. So the first y on the top plus x plus y, that's the bottom y, plus x. And remember, total fencing available is 720 feet. So what you got? You got 2y plus 3x equal to 720. Unlike the last problem where we had expression for our length and width, I'm going to actually use this equation to find one of the expressions for length or width. And it doesn't matter which one you find. So let's solve this expression for y. As I said, it doesn't matter. So 2y should be 720 minus 3x. What I do, I now divide both sides by 2 because I'm solving for the length or y. So I get y equal to 720 over 2 minus 3 half x, which is 360 minus 3 over 2x. Now remember, the area of this field is going to be length times width. So length is y times x is the width. So what I get 360 minus 3 over 2x times x. Again, like the last problem, I'm looking forward to get a parabola, which is a parabola, and let's call the area function to be fx. You want to maximize the area, so you want to maximize fx, and it is maximized because a in this problem is negative 3 halves, which is less than 0, so the parabola opens down, and that tells me the vertex is the point of maximum. It is going to answer all the questions. Okay, so what I do now, I find the vertex. So for the vertex, I'm going to first find h. H is going to be minus b over 2a, which is minus b is 360 in this problem. A is negative 3 halves. So that's good news because the 2 and 2 will cancel. Minus and minus will cancel. So I will get 360 over 3, and that is 120. Then finding k. So k is going to be, look at your parabola and put 120 for x. So this is 360x minus 3 half times 120 square. And again, I'm going to find this answer in my calculator to save time. So we're going to, and I think I missed, and it should be 120. So let's do it. We got 360 times 120 minus 3 halves times 120 square, and that's 21,600. And again, like the last problem, we actually have answered all the questions by just doing this much. So it asked you for the length of the fence. Remember, the length of the fence is given by y, and your y is given by 360 minus 3 over 2x. The width of the field is x, and we found x. X is the x coordinate of the vertex, which is 120. So that's 120. So the length is going to be 360 minus 3 halves times 120. So this is 360 minus 2 divides 120 and gives me 60. 60 times 3 is 180. So that should be 180. And the unit for all these are in feet. So I will say length is 180 feet, width is 120 feet. And the final question is asking you for the maximum area. Maximum area will be maximum value for fx, which is the k value. So we'll say maximum area is 21,600 square feet. So let's see what we have done so far. So as we have talked about, I just said the width is 120 feet. That's the width of the rectangular field. And then I have found out that the length is given by the formula 360 minus 3 over 2x. So putting x equal to 120, I cancel 2 and 120, got 60. 3 times 60 is 180. So 360 minus 180 is 180 feet. And then as we have talked about, the maximum area is given by the y value of the vertex of the parabola, which is k. So that is 21,600 square feet. Answers my question. A little different type of problem. So this one is saying that a frame of uniform depth for a shadow box is to be made from a 40-inch piece of wood. Write the function to represent the display area. What dimension should maximize the display? So this one is pretty simple. So what it is asking you, if x is the width and y is the length of the shadow box, then what is the perimeter of the shadow box, or what total amount of wooding is required for the boundary? Remember, this is x, this is y. So I will say total boundary, which will make through the wood, is going to be, I have 2 x's and 2 y's, and that is equal to 40 inches. So just like the last problem, let's solve it for y. So I get 2y equal to 40 minus 2x. So I divide both sides by 2. So I get y equal to 40 over 2 minus 2x over 2. And remember, this is going to be 20 minus x. Now I want to find the area, because this is what I'm trying to maximize. The area is going to be length times width. And again, the length is y, the width is x, so it's y times x. So I get to say area function, say fx equal to y, which is 20 minus x times x, and that is 20x minus x squared. Again, you wanted to maximize the display area. So I want to maximize fx. Think about the function. It is a parabola with a equal to -1, which is less than 0. So it opens down. That means I will get the maximum automatically if I find the vertex of this parabola. Okay, so we're going to find out h. That should be minus b over 2a. b in this problem is 20. So minus 20 over 2 times. A in this problem is -1. So I get minus 20 over minus 2, which is 10. Remember, this is the x value. So y, which is 20 minus x, this is the y, should be 20 minus 10, and that should be 10. So both the length and the width are 10 inches to maximize the shadow box. And let's find the maximum area of the display area. Well, I have to find the k coordinate or the y coordinate of the vertex. So I'm going to go back to my original equation of the parabola 20x, and x is 10, so this is 20 times 10 minus x squared, so 10 squared. 20 times 10 is 200, minus 10 squared is 100, and this is 100, and this is the maximum display area. So my final answer is the maximum display area is 100 square inches. Okay. The sum of two numbers is 22. What two numbers will maximize the product? So this time you are maximizing the product. So what I say, I start by saying let one of the numbers be x. Then the other number is what? The other number should be found from the sum. Remember, the sum of the two numbers is 22. So then the other number being y, I get x plus y equal to 22. Solve for y, so you get y equal to 22 minus x. Remember, you are maximizing the product, so the product should be x times y, which is x times 22 minus x, and that is 22x minus x squared. Again, remember, this is a parabola with a equal to -1 less than 0. So it should be opening down, and that pretty much tells you the answer. If you find the vertex of the parabola, you found the number that will maximize the product. Okay, so h is minus b over 2a. B in this problem is 22. A in this problem is -1. So I get -22 over -2, that's 11. So remember, this is your x. The other number y is 22 minus x. So y is 22 minus 11, which is 11. So both the numbers are 11. Both numbers are 11. Now I need to find the maximum product. So the maximum product is going to be the y value of the vertex, which is going to be 22 times 11 minus 11 squared. So 22 times 11 is going to give me 11 times 2 is 22. 2 carries on. 11 times 2 is 22 plus 2 is 24. Minus 11 squared is 121. So that's 121. So the maximum product is 121. And that would answer my question. The final problem is a problem where the parabola or the quadratic equation is given to us. This one is saying that the population P in Austria in thousands from 2000 to 2010 can be modeled by Pt equal to minus 4t squared plus 160t plus 80,000, where t is between 10 and 20. Where t is the year, with t equal to 10 corresponding to 2000. So question is asking me, according to the model, in what year did Austria have the greatest population? What was the population? Round both answers to the nearest integer. Okay, so this is a parabola again. What is a? It's -4, less than 0. Opens down. And you are already thinking that, oh, again, I'm going to find the vertex, and you were right, because I wanted to know the maximum population, the greatest population or maximum population. I need to know the vertex of this parabola as it is opening down. Okay, so what is h? H is going to be minus b over 2a. B in this problem is 160, so it's minus 160 over 2 times. A is -4, so 2 times -4. So I get minus 160 over minus 8, minus minus cancel, gives me 20. Now remember, this time the variable is t. So at t equal to 20 means in 2010. Why? Because t equal to 10 refers to 2000. So t equal to 20 refers to 2000 plus 10. So means in 2010, the population will be greatest. But what will be the greatest population? Well, all I need to do is find k. So I will go back to the parabola and use t equal to 20 in that. So negative 4 times 20 square plus 160 times 20 plus 80,000, which is going to be negative 4. 20 square is 400 plus 160 times 20 is 3200 plus 80,000. So this is negative 1600 plus 3200 plus 80,000, which is 1600 plus 80,000. And that should be equal to 81600. So the maximum or the greatest population of Austria in 2010 would be 81,600. According to the model, what will Austria's population be in the year 2140? Is this result reasonable? Okay, let's see that. 2140. So in 2140, it is how many years from 2000? 2140 minus 2000 is 140 years. Now remember, 2000 stands for t equal to 10. So 140 after that should be t equal to 150. So in your equation of population, you're going to put t equal to 150. So I'm going to get p of 150, the population p of t. So I'm going to find out p of 150. So we're going to get minus 4 times 150 squared plus 160 times 150 plus 80,000. I just put t equal to 150 all over. So I get negative 4 times 150 squared is 22500, so 22,500. Let's multiply. 15 times 6 is 90, so 9 carries on. 15 times 1 is 15 plus 9 is 24, and I will get 2 more zeros. So this is 24,000 plus 80,000. So when I multiply negative 4, I should get 0, 0. 4 times 5 is 20. 4 times 2 is 8 plus 2 is 10. 4 times 2 is 8 plus 1 is 9, but that's negative. So negative 90,000 plus 24,000 plus 80,000. So I get negative 10,000 from these two plus 24,000 should be 14,000. So I will say Austria's population should be 14,000 in 2140. And this was Austria's largest population. And that happened in 2010. Now the last question is, does that make sense? So we'll say no, it doesn't make sense. Not make sense. And why it does not make sense? Because this model of the population was good for the years 2000 to 2010. That's given in the problem. 2140 is beyond that mentioned years. So I will just say no, it doesn't make sense, as the domain of the function is 10 to 20 and 140 is not in the domain. And that would complete this problem. So we have answered all the question in this lecture note, and I'm going to stop here for today, and I'm going to let you start working on your homeworks. Now, this section is not very simple, even though the work is pretty similar every single time. So keep working on your homework. Let me know if you have any question.